We're going to be looking at another example of similar triangles, so let's just get into it straight away. Alright, so the thing that we need to do here, obviously with any of our triangles here, is to prove the similar first of all. Now we've got right angles in here, so I'm going to call this here angle alpha. Now for this particular big triangle, and I'll label the big triangle A, B and C, so we'll say let angle B, AC equal alpha. We can also say let angle BCA equal beta. Right, if we call that beta up there, or we could say that's equal to 90 take alpha, depending on how you want to label that. It's up to you. Right, if that's the case, then we know that this angle up here is a right angle, so therefore this angle here has to be beta as well, doesn't it? And then this angle here has to be alpha, right? Because there's 180 degrees in a triangle. So we have to sort of say that therefore angle A, B, now we don't have this thing over here, so we'll call that D. ABD has to be equal to beta, right? So 180 degrees in a triangle, and we know then that angle, what is that angle? CBD equals alpha, and that's also the same issue, 180 degrees in a triangle. So therefore, similar triangles, all angles equal. Excuse my writing. Alright, so therefore we've got our triangles there. Now for this here, we've got three triangles that we may need to use. So what I'd suggest you do is draw three separate triangles. I'm not going to do the table method for this one. Alright, I'm just going to do things. So when we're doing these triangles, we'll just draw them in the same orientation, and we label our angles the same. Alright, because we're going to do the sides. We basically label our sides from our angles. Alright, so we know all of these here are right angles there. Alright, so the first triangle I'm going to draw is the ABC one. Alright, so that's got a side there of 2 centimeters and 3 centimeters, and so therefore I can use Pythagoras to work out that as 3 squared is 9 plus 4 root 13 centimeters. Alright, the next one I'm going to do is I'm going to do where the right angle is, that's D, and I've got the side where alpha and beta, that's going to be AB, alpha beta, so that's A and B. Right, so we know that this side over here is 3 centimeters. This is going to be X. Now that may be enough, and in this particular case it is, but sometimes you don't have enough and you have to use your other triangle there. D is the angle there, beta is C, and the other side over here is in fact alpha, which is B. And that would mean alpha D is going to be X, and then BC is going to be 2. Right, so therefore that's another side I could use. So I could use any of those three triangles. I do have three triangles there. So the main thing is we pick a technique. So let's use this triangle here and this triangle here. Put my unknown at the top left hand side. X2, 3 is the same as 2 root 13. So therefore X is going to be equal to, 3 goes up to the top there, 6 over root 13 centimeters is what X is equal to. So I've used my concept there, the right angle triangle, to do that. Now in this particular case here, if we get rid of the circle bit, if you can imagine that circle bit not being there, we've got the same question, it's just a little bit of a different orientation now. If we're using the angle subtended by a semicircle as a right angle there, that's all we have to use, and now it's the same question as what we listed over here before. Alright, so you might need to use that for that particular activity. Come down, we'll go have a look at another question. Question 7 in your textbook has got this one here, which is a symmetrical truck driving through a tunnel. Now, I need to draw some things on here. Alright, I know that's my radius going there. Okay, I could draw a perpendicular line going down there as well, and that would give me also a radius there, which I know the length of. Excuse my diagram. And then I could draw the perpendicular down there, which would be my height. What do we know about this? We know the truck is 3 metres wide. Alright, so, and again, I can use similar triangles. I can use any technique to get the answer here. Excuse the diagram. So if we've got our diagram here, we've got a line there, we've got a line going out there, drop a perpendicular down here. I know this distance here is 1.5 metres, don't we? This is our height that we're trying to work out. We know our radius is in fact the right angle there. We know our radius is 3 metres there. That actually is enough information to work out h. I'll let you do that. Alright, so if not, we could also use a concept of, you know, that being a right angle and using a similar triangles as well. So there's different ways of doing it, but I reckon that one's quite straightforward. 10, we have to think of this being a 2D diagram from a 3D scenario. Alright, so here we've got a cylinder, imagine drawing that there. We've got our line going across here, which is our radius. Alright, and so therefore that's what we've got. Can you see, if we were looking at that and comparing that with the diagram over here where we've got A, C, there, we have essentially the same diagram, don't we? Alright, so for questions like question number 10, what you have to think about is this being a 2D scenario. Now, it's going to be quite easy to prove that these are similar triangles. They've got a common angle up here. Right, they've got this angle here, and they've got the other angle down the bottom, which are going to be obviously equal, and they've got 2 right angles down on the base here. Alright, so these 2 are right angles, that angle there have to be the same, and because they've got the common angle at the top, so that should be a fairly easy proof. And now we're just going to use the similar triangles to solve the rest of that question. Again, I don't want to do it for you, I want you to have a go at doing it. But the secret with any of these things where you've got the 3D scenario is to make sure that you think of them being a 2D shape. And then probably the easiest thing to do from that is to even simplify the diagram again and only draw the part of the diagram that you actually need. Right? So you need to only draw that part of the triangle which is shown there in red. Alright, and you can then label that and then solve that as a question. Right, so we'll have a bit of time in class to work through some of these questions together, and also you working through them as well.